SpaceX builds 300 plus engines while Blue Origin makes just dozens? That's right. The production gap is absolutely shocking. While Elon Musk's team cranks out one Raptor engine every single day, Blue Origin celebrates building dozens per year from their massive factories. But here's the real kicker. Each SpaceX engine costs $500,000 versus Blue Origin's $8 million each. So how is this insane difference possible? Let's dive right in. Here's where this story gets absolutely insane. While the entire aerospace world was focused on who could reach orbit first, SpaceX was quietly building something that would change everything. A rocket engine assembly line that produces more engines in a single month than most companies build in their entire existence. Picture this. At SpaceX's McGregor facility in Texas, every single day at exactly the same time, a brand new Raptor engine rolls off the production line. Not every week, not every month, every single day. By late 2022, they hit the impossible milestone, 365 complete rocket engines per year from one facility. That's one engine every 24 hours, including weekends and holidays. The numbers are so staggering that when industry experts first heard them, many thought it was a typo. But here's where it gets even crazier. They've actually slowed down production recently. Why? Because they're focusing on quality improvements for their next generation Raptor 3 engines. Even at this reduced pace, they're still manufacturing around 300 engines annually. Meanwhile, Blue Origin, with their massive 600,000 square foot facilities spanning Washington and Alabama, celebrates building dozens of engines per year. Let that sink in. Dozens versus hundreds. But the real shock comes when you see the price difference. This is where Blue Origin's strategy completely falls apart. Each SpaceX Raptor engine costs approximately $500,000 to build. Each Blue Origin BE-4 engine, a jaw-dropping $8 million? That's not a mistake. We're talking about a 16 times price difference for engines that do essentially the same job. But how is this possible? SpaceX revolutionized everything by treating rocket engines like cars rolling off an assembly line. They embraced 3D printing technology, automated manufacturing, and mass production techniques borrowed from the automotive industry. Every process was optimized for speed and scale. Blue Origin stuck with traditional aerospace manufacturing, small batches, extensive hand assembly, and artisanal craftsmanship. Each engine is essentially handcrafted like a luxury watch, which sounds impressive until you realize it makes space exploration prohibitively expensive. This cost difference isn't just about bragging rights. It fundamentally reshapes what's possible in space. SpaceX can launch their massive Starship for just $2 to $3 million per flight. Blue Origin's New Glenn? The engine costs alone make this price point impossible. But there's something even more shocking about how these companies ended up in such different places. While the public watched legal battles and press releases, a secret manufacturing war was raging behind closed doors. This wasn't just about who could build better engines. It was about who understood the future of space exploration. Blue Origin's approach seemed logical. Hire the best engineers, build the most sophisticated facilities, and create the most advanced engines possible. They massively expanded their Huntsville facility, installed cutting-edge equipment, and hired hundreds of specialists. But SpaceX was playing a completely different game. While Blue Origin was perfecting individual engines, SpaceX was perfecting the system that builds engines. They weren't just making better rockets, they were making better rocket factories. The breakthrough came when SpaceX realized something revolutionary. The bottleneck in space exploration isn't technology, it's manufacturing. You can design the perfect engine, but if you can only build a few per year, you'll never make space accessible to everyone. This philosophy led to a radical decision that shocked the aerospace industry. SpaceX implemented what Elon Musk calls the algorithm, a manufacturing philosophy that questions every component, every process, every assumption. The first rule, the best part is no part. The best process is no process. This led to the revolutionary Raptor 3 engine, which looks like someone stripped away half the components from previous versions. Industry experts initially thought the first photos were fake, Surely this couldn't be a complete engine? But it was. By integrating multiple components into single pieces using advanced 3D printing, SpaceX eliminated thousands of potential failure points. Each Raptor 3 weighs 170 pounds less than Raptor 2, while producing 100,000 pounds more thrust. The visual difference is staggering. Raptor 1 looked like what engineers call flying spaghetti monster, a maze of cables, sensors, and external components. Raptor 3 looks almost skeletal, with clean lines and integrated systems. Blue Origin's BE-4 still uses the traditional approach: thousands of individual components, external wiring, and complex assembly processes. It works, but it's fundamentally limited by its complexity. But there's an even bigger twist coming that nobody saw. Here's where Musk's vision becomes truly audacious. SpaceX's long-term goal isn't just to build more engines. It's to build 1,000 Starship rockets every year. Do the math. Each Starship needs about 39 Raptor engines, 33 for the booster, 6 for the upper stage. That means SpaceX will need to produce 39,000 engines annually, more than 100 engines every single day. This isn't science fiction. SpaceX is systematically building the infrastructure to make this reality. Their current 300 engines per year is just the beginning. When Raptor 3 reaches full production, they expect 400-plus engines annually from existing facilities. But they're not stopping there. New production facilities are planned, manufacturing processes are being automated, and supply chains are being optimized for unprecedented scale. Meanwhile, Blue Origin celebrates producing dozens of engines per year from facilities larger than SpaceX's entire operation. But raw numbers only tell part of the story. The technology gap between these engines is equally staggering, and it reveals why SpaceX's approach is fundamentally superior. Both engines use liquid methane and liquid oxygen, a modern fuel combination that's cleaner and more efficient than traditional rocket fuel. But that's where similarities end. Blue Origin's BE-4 produces 550,000 pounds of thrust using oxygen-rich stage combustion. Think of it as a two-stage process. Some fuel burns to power the pumps, then the main combustion happens. It's sophisticated and represents solid engineering. SpaceX's Raptor 3 uses full-flow stage combustion, the first engine in history to successfully implement this design at scale. It has two separate pre-burners working together, creating more complete combustion and reducing stress on components. The performance difference is brutal. Raptor 3 produces over 610,000 pounds of thrust. That's 60,000 pounds more than before. It achieves 350 seconds of specific impulse compared to B4's 310 seconds. In rocket terms, this means SpaceX engines can carry more cargo further while using less fuel. But there's something even more shocking about what this technology enables. Here's where this story takes a fascinating turn. Despite SpaceX's overwhelming advantages, both companies are heading to the moon, and the timeline might surprise everyone. NASA awarded SpaceX the contract for Artemis 3 lunar landings using Starship. But Blue Origin also received a massive $3.4 billion contract for their own moon lander, launching on New Glenn rockets with those expensive BE-4 engines. Blue Origin's lunar mission could happen as early as March 2030. If they succeed, it would prove that expensive, low-volume manufacturing can still achieve remarkable things. It might even shift public attention away from SpaceX's manufacturing dominance. But here's the critical question. Can Blue Origin's boutique approach compete long-term with SpaceX's mass production strategy? The January 16th moment perfectly illustrates this dilemma. January 16th, 2025 was supposed to be SpaceX's day. Starship's 7th test flight was expected to demonstrate their latest innovations and bring them closer to orbital success. Instead, something extraordinary happened that nobody predicted. Blue Origin's New Glenn rocket successfully reached orbit on its very first launch attempt, a stunning achievement that typically takes multiple tries for new rockets. That exact same day, SpaceX's Starship test ended in spectacular failure, with the vehicle breaking apart during ascent. For one brief, shining moment, Blue Origin looked like they were winning the space race. Their expensive, carefully crafted BE-4 engines performed flawlessly. Their traditional approach suddenly seemed vindicated. But here's what makes this moment so revealing. While Blue Origin celebrated this single successful launch, SpaceX was already analyzing failure data, planning improvements, and preparing for their next test. They treat failures as data points in a larger optimization process. Blue Origin treats each launch as a make-or-break moment. SpaceX treats each launch as one step in an iterative improvement cycle. This fundamental difference in philosophy explains everything about their production numbers. The production gap isn't just about manufacturing capability, it's about completely different visions for humanity's future in space. Blue Origin's approach makes sense if space exploration remains an exclusive activity for governments and billionaires. Building dozens of expensive, handcrafted engines per year is sufficient for occasional high-profile missions. SpaceX's approach only makes sense if you believe space travel should become as routine as commercial aviation. Their 300-plus engines per year strategy is designed for a future where thousands of flights happen annually. The cost difference reflects this vision. At $8 million per engine, space remains expensive and exclusive. At $500,000 per engine, space becomes accessible and routine. But there's one final twist that reveals the true scope of this competition. Here's something that will blow your mind. SpaceX's current production numbers aren't even their real target. The 300-plus engines per year they're building now? That's just testing their manufacturing systems. When Raptor 3 reaches full production, which could happen within months, they expect to build 400 to 500 engines annually. But even that's not the endgame. SpaceX is quietly developing automated production lines that could theoretically produce multiple engines per day. They're applying lessons learned from Tesla's automotive manufacturing to rocket production. The goal isn't just to beat Blue Origin's dozens of engines per year, it's to make everyone else's production numbers look quaint. Meanwhile, Blue Origin's dozens of engines per year represents their maximum sustainable production rate using current methods. They're operating at capacity while SpaceX is just getting started. But the most shocking revelation is what this means for the space industry. The aerospace industry has spent decades convincing everyone that rockets must be expensive, complex, and built in small quantities. This belief justified enormous government contracts and kept space exploration exclusive. SpaceX's production numbers shatter this narrative completely. They prove that rockets can be mass-produced like any other industrial product. The only question is whether other companies will adapt or become obsolete. Blue Origin's dozens of engines per year represent the old way of thinking. SpaceX's hundreds of engines per year represent the future. The implications extend far beyond engine counts. If rockets become mass-produced consumer products, everything changes. Space tourism becomes affordable. Satellite launches become routine. Mars colonies become economically viable. Blue Origin's approach can support occasional missions to the moon. SpaceX's approach can support permanent human presence throughout the solar system. The production numbers tell the story of two completely different futures for humanity in space. So here we are, SpaceX producing 300-plus engines while Blue Origin celebrates dozens. But this isn't just about numbers anymore. We're witnessing the moment when space exploration stops being science fiction and becomes industrial reality. Every Raptor engine rolling off that Texas production line brings us closer to a future where your kids might vacation on Mars. Blue Origin's approach works for today's space industry. SpaceX's approach is building tomorrow's space economy. The real question isn't who wins this engine race. It's what kind of future we want. Do we want space to remain an exclusive playground for the ultra-wealthy? Or do we want it to become humanity's next frontier? Because somewhere in a Texas factory right now, another Raptor engine just finished production, and tomorrow, another one will follow. What do you think? Are we ready for a future where space travel becomes as common as air travel? Let us know in the comments below, and make sure to subscribe for more deep dives into the space race that's reshaping our world. SpaceX just got blindsided. While they're stuck with complex, multi-launch refueling nightmares, Blue Origin dropped a 90-day moon landing plan that's so simple it's genius. Their 8-meter lander needs just one launch to reach the moon. No assembly required. China's scrambling with 2026 plans. SpaceX pushed to 2026, but Blue Origin, summer 2025. How did the slow company suddenly become the frontrunner? Let's dive right in. Here's the bombshell that changes everything. While the world was distracted by SpaceX's exploding rockets and China's grand announcements, Blue Origin quietly secured a $3.4 billion NASA contract in May 2023. Not for some distant future project, for a moon lander launching this summer. Think about that timeline. SpaceX has been developing Starship since 2016, 8 years of testing, explosions, and setbacks. China's been planning Chang'e missions for over a decade. Blue Origin ? They announced their Mark 1 lunar mission in March 2024 with a 12 to 16-month deadline. Either Jeff Bezos has lost his mind or Blue Origin has been playing the longest game in space history. Everyone's been asking the wrong question. It's not how did Blue Origin catch up? It's when did they actually start? While SpaceX grabbed headlines with Starship belly flops and rapid unscheduled disassemblies, Blue Origin was doing something completely different. They were building hardware that actually works. Their PlanetVac sampling system, already operating on the moon's surface. Their Lister drilling equipment, successfully deployed and collecting data. But here's where it gets really interesting. Blue Origin's Mark 1 isn't some revolutionary new design they dreamed up last year. It's the culmination of over a decade of quiet development. Remember, they've been working on lunar landers since 2011. SpaceX only started seriously pursuing moon missions after NASA's 2019 Artemis announcement. Who's really behind schedule here? Let's talk numbers that will blow your mind. SpaceX's Starship weighs 5,000 tons fully fueled. Blue Origin's Mark 1? Just 3 tons of cargo capacity, standing only 8 meters tall. That's pathetic, SpaceX fans will scream. Starship can carry 100+ tons. Here's what they're missing. Blue Origin doesn't need to carry 100 tons to win this race. They need to carry 3 tons and actually land it successfully. Think of it this way. You're racing to deliver a pizza. SpaceX built